Okay, we are live. So welcome everyone on the Node.js Diagnostic Working Group meeting, 2019, September 25. Today's meeting is different than the usual one, meaning that today we will discuss one of the deep dive topics around diagnostic use cases, user journeys, and tutorials. And we picked the crash analysis as the first one. So today we will talk about both how we want to work together on these two topics, kind of figuring out what are the use cases, what are the available tools, what are the user journeys today, what would be the ideal user journey, and what kind of documentation, other helping materials we can provide to the community. So today is the first one, as I mentioned. So it's a little bit will be mixed, both figuring out how we want to work on this and to discuss the actual deep dive topic, which is the process crash. We linked the document to today's meetings. Actually, it's cross-linked both in the original Diagnostic Working Group notes document, and we have these separate documents which we will use today. So you can find the link in both the GitHub issue and in this Zoom meeting. Okay, so what was in my mind, how we could facilitate this meeting today is kind of start to come up with use cases, what we know as both the users and Diagnostic Working Group members that people may want to do around process crash analysis. Then we could kind of discuss how we are debugging today those, what are the tools and what are the gaps. So what would be the idea where we want to be? And we should also discuss that what we want to start to recommend to people and what documentation would be required for that. What people think in this meeting about this kind of agenda. In the meantime,
sounds good.
Share my screen. Okay. Do you see the document shared?
Yes.
Yes.
Yep.
Okay, about the use cases, I have no better idea than I start with one that I know, and I would like to hear what other people are facing issues around this, or know about that their customer facing, and hopefully we start to have some kind of list what we can work with that. Does it sound good to the people here?
Yep.
Okay. So what's probably really Netflix specific or platform specific is that our use case is basically my team is building a platform where people running, let's say, arbitrary code, black box code from our team point of view, because we are just providing a platform and operating. So when we start to see crashes, then sometimes it can be really hard to kind of inspect the process in the postmortem in a way, or kind of gain enough data to really figure out what happened. So sometimes the error message and the stack trace which was thrown have enough information for that. Sometimes doesn't. And the use case is when it doesn't have enough information is usually when either the stack trace is like it's happening in a third-party library which has a really deep stack trace and the error message is not very useful. This is an example when, for example, you use the official gRPC library. So when you make an issue like when you pass a negative number to positive integer strongly typed proto buffer, then it blows up. The error message is not useful. The stack trace is not useful because it's inside the library. So it's kind of a black box, what's really happened in the process. And another use case is when someone is catching the error and rethrowing. This is really usual with promises or try-catch or RxJS or those kind of things. And what you see is stack trace on your console is not the original stack trace. So you kind of need a way to find the error in the process and kind of read the original stack trace and other error properties. So that's the two, but actually I already put in this document as a to-do. One is kind of let's call it when there is some third-party library without useful stack trace, and another one I just called it finding the original stack trace at restro. That's the two use cases that I can bring to this conversation. What other people has in their mind?
I guess like if we look at the document that Jarish put together with the crash use case, I mean, the crashes could also be like a sea-level crash in the process, right?
Yeah.
So I don't know if that's like in terms of the original documentation, it makes sense to combine those, like, right, okay. So like it's, right, because it's kind of like...
I would say let's put everything that's related to crash here, and then later if it's need, then we can categorize or create more deep dive if it's necessary.
The way I look at it is, at least there are two different class of issues which comes under the crash after listening to the explanation of Peter. One is basically low-level crashes such as C crash, etc., which do not leave a trace of a stack trace for whatever reason. Whereas the crash context and the failure data is crisp and precisely available if you debug through a core dump debugger. That is the first class of issue. The second class is basically through some abstraction such as a third-party library, etc. The original failing context is completely masked off, and you are providing a sophisticated error message, propagating that through a different control flow path. And at the time when you are intercepting the failure, you completely lost the original context. And I don't think the crash diagnostics is going to have any association with that or any usage, anything that can be helped in that scenario.
Well, except that I think some of the stuff you have in your document is about being prepared for those environments in terms of, like, you know, do you have the view limit set, and is there any commonality in those two situations?
Yeah. I mean, the only commonality would be like there is somebody such as a low-level tracing which intercepts the origination of the first error and then generates a core dump in response to the creation of the first error. And then that core file has complete information that you're looking for, and the PR is a prereq. It shows all the prereq that is required for generating the core dump. Yeah.
Right. So if it's in those cases, we're going to want to have a core file, then there at least is the commonality in terms of what you need to be ready for in terms of those core files, right?
Yep.
Okay.
So before we really jump to core dumps and kind of ways to find it, it kind of resonates, the second one, the error message is tempered by the error handling pipeline, which what I shared. So I think, and can you talk a little bit about the low-level C-like use cases? I know it can happen, but to be honest, I didn't run too much into this, so I have a really limited context about why it can happen and how it can happen. Could you maybe share some examples around it?
Yeah. So basically, if you look at the way Node.js is abstracting the JavaScript APIs, it internally makes use of V8 APIs, and almost everywhere in the V8 APIs, be within the API or at the call site of the API, you have macros to validate the sanctity of the input and the output. For example, you will see checks and dechecks. These are basically to make sure that you don't get unexpected results because of a user error or a completely bogus input or output. Now, it's so possible that at some because of some bug, these checks are missing at some control flow paths. And when the application undergoes that control flow path, the side effect is that it can crash in a highly unexpected manner without without having any proper JavaScript call stack, possibly. It will be as good as a vanilla C program that is crashed.
I think also.
Don't they normally also show at least the last JavaScript function that executed it?
Ideally, yes. There is a abort hook that is installed by the V8 even before the first JavaScript piece of code is executed. But I have seen very plain primitive crashes as well without any intersection by the virtual machine.
Right, and I guess in that case, even if it does include the JavaScript stack, you need to be set up to be able to get those core dumps and introspect them and get them off the production machine, which is part of what the other doc Jewish put together covers.
Yeah.
The other thing I'll add to that one is, like, in addition to something in V8 crashing, anytime your application uses native modules, the native modules can also cause, Node to crash.
Yeah.
And that's probably where, you could be using modules which don't have as heavy a usage or as broad a usage as the core runtime itself. So it's potentially, I think, more likely to.
Agree.
Okay, cool.
Is there one more type maybe? So what I also, and like what's normally also difficult to debug is if you have a memory leak and your process crashes and because your process runs out of memory. And that's also pretty difficult to debug because you don't know where it's coming from.
Yeah, not a heap memory leak.
Yeah.
Like not a GC, GC managed heap memory leak, but an actual like native memory leak can definitely cause that kind of thing.
Okay, cool. Then maybe I will move my use cases under the tempered one. I think these categories are really great. And maybe this one under the low level. So it sounds like we have two bigger categories. The low level one, which can be by V8 internal bugs checks based on the user input, can be caused by native module crashes and memory leak in native modules. And we have another bigger category, which is mainly when the error is tempered by the error handling pipeline, which couple of examples can be the third-party libraries kind of not making a really good job of making the errors. And another can be we are simply restoring errors, wrapping errors, or doing other things with error, which causes the original error message and stack trace kind of hidden in the console output. Is it a good summary of what we have now?
Isn't the second one more like that you can have things like unhandled exceptions, unresolved promises, which depending on your options can cause you to exit? And then under that, you can either have one that gives you a nice, good stack trace where it's like obvious what is happening, or one where you've got that problem of the tampering.
Okay, I like that. Let's break it down to more. So we have unhandled rejection, uncaught exception, and one category is the problematic one, and another one when stack trace and error message has enough sufficient information to really know what's happened.
Yep.
And I would like to clarify on the first bullet, which is V8 checks when input check is missing can lead to a crash.
Yes.
Basically, what I meant is the check missing is not necessarily the root cause of the crash. Check missing is causing the manifestation to be of the vanilla crash. If the check is present, then we would see a more decent error message, probably an optional crash as well. The actual root cause could be any bug in the virtual machine or in the data or in the application. The check missing is actually causing the sophisticated error catching mechanism leading to row crashes.
Okay, I slightly changed that. How does it sound now?
What about until I think Node 12, we never showed properties on errors, for example, when we logged them. That's different now. So now we definitely log properties all the time when they're directly on the error as an enumerable property. But we often create errors in various ways and often also have properties on them that are non-enumerable due to being on the prototype, for example. What opinion do you have about these things? Should these properties be visible by default? It might be a bit off topic, I'm not totally sure.
That's a good question. So I would say that maybe, do we have any other use case? Because if we don't have, we can move to discuss how
I might generalize the one you have there. Like basically it's again, the first one is kind of like bugs in the Node.js runtime or one of its dependencies, right? Because really you shouldn't be able to cause the runtime itself to crash. Whatever you do should basically end up with an exception or a rejection or something.
Yeah.
And I guess because like, I mean, Jarish, correct me if I'm wrong, but even in the case where there's a missing check, some other bug must have allowed that call to be made, or it's a bug that, you shouldn't be able to pass data. It would be a bug in Node potentially calling V8 in a way that wasn't intended, right?
Makes sense to me. Okay, we mentioned code dumps. Ruben mentioned the error properties. Do we have other use cases, or should we move towards what we have today?
Just thinking, are there any other things that cause unintended, like basically you exit?
We lost Giresh in the meantime. Hopefully he will.
Oh, hopefully he's rejoining, yeah.
I don't have anything else in my mind at the moment.
Have you ever run into cases where like bugs in the code cause you to exit? I guess those are more unhandled exceptions or rejections or something.
Yeah, so at Netflix, we have many of them because our philosophy is that we crash the process instead of keeping it in inconsistent state.
Right.
So, but I know, for example, people who are using Express.js, the Express.js has a try catch in the middleware, so synchronous error happens, then the Express.js basically catches that and doesn't crash, and the promise also catches errors. So my feeling is that maybe in the new type, more modern applications, it's less frequently that programmatic errors make the process crashes, but I'm not sure actually. Maybe Ruben, what's your experience? I know you did some consulting recently.
I'm sorry, can you just repeat that?
Yeah, so the question was that what's the percentage nowadays around application crashes from programmatic errors? And then we started to discuss that because Promises catches them and the Express has a try catch. Maybe it's less frequent now that actually applications crashes because programmatic errors. But and I was just asking what's your experience, because probably you were the most involved with many user applications.
I think you need to promote Jarish as well.
It's hard to give it like a concrete number.
But I was more going at it from, is that a different use case? Like is there a, you know, say at Netflix, if, you know, you basically said you say, well, if we're in an inconsistent state, we want to exit. Is it that you throw an exception at that point? Or is there like, you know, do you call process.exit, or is there some other way that basically the running instance terminates?
Yes, we are throwing an exception.
Okay, so that's probably covered under that one.
Yes.
Okay.
Okay, then maybe let's move to the tools, and later we can always come back and then multiple use cases. So I added a couple of tools in this table, which I had in my mind, but it's a good point that actually what Ruben mentioned, kind of we can see it as a tool that, that now we have the new error property printing, which I will put it as error properties. And one gap is for sure what you mentioned, that non-iterable properties, like properties not printed. Okay, so we have 3 tools in this table. I mainly, again, I was working what was in my head. At Netflix, we use code dumps heavily, meaning we are running our process with abort uncaught exception. And we have a way to download the code dump and then analyze, and we use it to find original stack trace. And when it's usually useful when errors are tempered, or at least that's the most common use case when we need to use it. I know IBM was heavily involved with the diagnostic report, and Ruben was involved with error properties. Do you want to talk about those tools, or you are more familiar with use cases?
Yeah, diagnostic report originally was a third-party module called Node report. Basically, it gets connected with the application, runs in a different thread, I believe, in the original tool, and then inserts the hook for signals and unhandled exceptions and things like that. And it also has the ability to call in to collect reports on demand, basically API based report generation. The whole idea of report is to provide a snapshot of the running virtual machine, looking from different aspects: the JavaScript heap, the overall native memory, the versions of the subsystems, the libuv state, the loaded shared libraries, and the environment variables and things like that. Basically looking from a diagnostic engineer's perspective and see what are the most useful information he would be interested in, and capture all those things in one single readable file, text file. That was the philosophy behind Node report. When it was integrated into the core, the objective slightly changed. Now we made it into a JSON formatted report. Other than that, fundamentally the content remains unchanged. The philosophy basically is the same: provide as much as useful information collected in one shot from the running application.
Okay. I know the diagnostic report is very general because it has a lot of information. Can we look it from the use cases point of view where it can be useful?
So, you know, for example, if you, you know, if say it includes information about U limits, and, you know, those are the kinds of things where, like, so for example, if you had a U limit that constrained your memory to be too low, and that's ending up causing you crashes, or if you're getting an unhandled exception because, you know, you can't create a socket, open a file, you know, the U limits can help you understand at a quick shot, it's like you can look at those and say, oh, well, okay, yeah, you're having troubles with memory because your ulimit is setting you to the point where you don't have enough memory to run properly, or you know your application creates a whole bunch of sockets, but the ulimit's set so that it's too low for you to be able to do that. So it helps with that kind of side of things. In terms of crashes, it does include some information, right, Jarish, in terms of the stack traces?
That's right. Yeah.
Now, I think the regular crash includes a stack trace as well, does it? So is it the same, or is there an extension in that case?
So if you are looking at the plain crashes that is controlled by the V8, you get the JavaScript stack trace, whereas the one which is controlled by the diagnostic report, you get both JavaScript stack as well as the native stack. Of course, depending on the use case and the specific control flow point at which the crash has happened, the native stack can be of great value or of no value.
Right. So, but that'd be an example of where if your crash is in add-on, that could actually be quite useful.
Yeah.
Okay. So based on the configuration, because it's highlighting the configuration, the native stack trace, maybe the diagnostic report is something which is more useful in the native related use cases in the first category. Is it fair to say or not really?
Well, the things like the uncaught exceptions, I think you can end up with, like, if you have a process limit and the run, the VM or node does the right thing, and instead of crashing says, wait a sec, I can't open this file, or I can't create you a new socket, I think you would end up with an exception. And so I think in those cases, it's just as useful, right?
Okay.
The other thing it includes is shared libraries. I know one that Jarish ran into was a mismatch in the shared libraries, and that information helped figure that one out.
Yeah, that was basically we have different types of distributions of Node.js binaries, and for example, in certain Linux distributions, they have the option to bundle the OpenSSL versus linking against the existing OpenSSL shared libraries in the system, etc. Now, just by looking at the Node.js version, you wouldn't know which SSL version, library is being linked against the executable. In this particular scenario, the application was crashing in one of the SSL routines. Just by looking at the listings from the diagnostic report, it was very evident that it was using, it was supposed to use the inbuilt library, but because of a overriding mechanism, it was connecting to a wrong library, and that led to wrong offset calculations and crash. So it was just a no-op once we had the diagnostic report data.
Okay, cool.
I guess if the exception that you get is like a regular GC out of memory, diagnostic report also includes some information about recent GC activity. So you might be able to tell, like, okay, well, wait a sec, just before I got my out of memory, I was GCing like crazy, and here's, the old space size was full, or whatever, that kind of stuff.
Okay, cool. I guess everyone mentioned code dump, so I guess everyone is familiar. Just let's put a couple of points. If someone reads these notes after the meeting, then knows kind of what it is.
I mean, it lets you, it's got a full memory image of what was going on. So you have much more, you have a more complete picture, right?
That's true.
It's really just more work to extract the info from it.
Last time you were also saying that you are able to capture the original error context from the core dump.
Yes. And you can also read the error properties.
Now, are you always using LL Node for that?
Yes.
Right. So I wonder if above it should almost be core dump / error / LL Node. Yeah. Possibly in the table too, because it's kind of like it doesn't, you can't use it. The core dump is very hard to use just on its own.
Yes, I agree. Okay, what else do we have? I guess we have the new error properties feature, which is not really a tool, but I believe it can replace some of the use cases. Ruben, do you want to talk about the error properties?
Just as I said before, like for a long time, Node.js did not print errors fully. It just printed the stack trace, and the stack trace contains the actual stack frames, and it also contains the error message and the error name, while it might not be the actual name of the error class, because if you have a subclass of an error, then it normally only prints the native class name. So let's say you have error class foo extends type error, then it will say type error, not foo, if you don't explicitly add the name to the class foo, while instantiating an error or giving it prototype property on it. And we did not show any error properties, which was quite bad. Also with node errors, we have a lot of properties at times about error codes when we have FS, so any file system involved calls, and users could not debug that that well because information was missing. And they also do not have the information about what properties the error might actually have to access them programmatically. So it's just, it was a bad situation, but this is solved right now. So also, let's say you have a nested error. The whole error is normally visible by now, if it's not nested too far. And it will contain all the properties that are enumerable. But we still have multiple properties that would not be visible. As such, especially when you have error subclasses, and you might have some not static properties, but like a kind of on some classes that you just have on a prototype. And you know every instance can access that property and programmatically, but you actively have to know about the property because it will not be printed by default. And my question is, should we actually make sure to print those as well? It would be maybe a bit weird, but maybe it's also useful for end users.
Was there any discussion about that before? Like, was it a conscious choice not to print those?
I think it was not a conscious choice. I think it was just historically, because and like if you think about error toString, it is exactly what it was before, and that's how it was printed since I think the beginning of Node.js until I changed it to also include. No, wait. I'm not sure about all properties. It might have printed in some cases some properties, but normally it did not. And now it definitely does. Sorry. It did not show them when you crashed. That was it. It did show them when you actively logged them. Yeah.
So if you did an error to string, you would get them, but you wouldn't get them when you crashed.
Yeah. So until recently, when you crashed, we only inspected the error on the C++ side, and we didn't use util inspect on it. Now we actually use util inspect to inspect the error and then print that on the terminal when crashing.
So in terms
and
of
that's why we get the error properties now.
Right. So and the reason why we don't get the other ones you're thinking about is just because inspect doesn't show those, right?
Yes.
And what's the downside of including them?
We might show, like, it's difficult to distinguish all these properties, because if you think about the prototype and how people might create an error, there are really lots of ways how people do that. It's not only about ES6 classes, but also about the old prototype style. And then if they have like a kind of a super call or not. So how you could detect these properties is actually by going down the prototype and then checking the prototype properties, and then removing, let's say, if there's message or name or toString, and also remove all that are a function, but all other properties that have a primitive in them or that are a getter, they might be inspected, and that would probably be valuable to the end user to improve their debugging experience. It's just not absolutely reliable, because you could have like multiple layers of prototypes, because you have like a superclass and the subclass. The superclass has another superclass. So.
Right, and I guess the question is if the information's in those superclasses are useful in the particular error failure, right?
Yeah. Yes, that's pretty much my question.
I mean, more information, I guess, is better, but to be honest, we are not a Node.js, so I don't really have the experience of even what having the properties means.
But it's not about the core dumps, really. It's just about getting more information to the user.
I mean, these are kind of related in my head, because if you have more information when the stack trace is thrown on the console, maybe you don't have to use code dumps, which is actually great.
I see it as a layer. You know, if you have the initial stack trace, that's great. Maybe that helps you solve it. Then you've got like the node report, which has a little bit more information. And then if none of those help you, then you got to move to the core dumps, right?
Oh, there's one more point when we talk about the stack frames. So when we have a recursion algorithm, for example, we often have a lot of frames that are not useful in the end. And you don't see the actual occurrence anymore, because we only track 10 stack frames at the moment. And so we might consider at least removing recursive algorithms in Node Core, so that a user stack traces are visible, and reduce our stack frames as much as possible to keep the original user stack frame in there. no comment on that.
I'm just thinking, would it ever make sense to have, like, you know, if you could tag all the internal stack frames and hide those, but that
We
sounds
already
like
do that.
quite a bit of work. Okay, so we already hide. So what are the extra ones you're talking about?
But it's working. So you can't actively say that we do not want to track Node core frames. We cannot distinguish that before getting the stack frames. What we can do is to hide them after serializing the stack frames. And that's what we are currently doing. I think I implemented it in Node 12. I'm not sure if it's backported. I think it's Semver Minor, where we now gray out the Node core frames, but it's done after serializing them. So we already collected the stack frames, and now the default is 10. And let's say 9 of those are Node core things, and only a single one is a user frame, but maybe it's not the original user frame. In the worst case, we have a recursion algorithm in Node core, and it's more than 10 stack frames. So the user stack frame is not visible anymore. Even if we hide the Node core frames, because then we would just have 0 frames left.
Right. Yep. So what's the question? Like, is it a good thing to do to try and make that better?
So we might try to reduce the amount of recursive algorithms in Node core. And also, I would like to start thinking about how can we reduce Node core stack frames in general to the absolute minimum. Maybe even discuss with the VA team if it's possible to distinguish specific frames to track, don't track them pretty much, or not to count them towards the number 10 as a limit. That would be pretty cool. So let's say you have the 10 stack frame limit, as it is by default now, but we could tell V8 not to track specific frames to that number, to that counter. So we would get at least 10, up to 10 frames from the user. That would improve a couple of use cases, because you also have modules. So it's not only applying to Node core in this case, but it could also apply to Node modules, where the module implementer could say, you, I don't know, could track, skip tracking those or something like that.
I think it's interesting to be able to tag, although it'd be like, yeah, I don't know how those would be identified or how you would flag them, you know, properly, but to say, okay, I don't want Node ones, but I want the other ones.
Yeah, I guess you could maybe, I don't know if it's possible. I would definitely, we have to talk to the VA team to get some further insight, but maybe it's possible to say, to give a specific file name and like a full file name.
Right.
And then no frames inside of that file might be tracked.
Yeah, it depends on how they keep them and if they can efficiently figure that out or not.
Yes, exactly. That's probably the main problem.
But I think like we don't have a huge amount of time. I think what we'd want to do is to try and capture our use case and recommendations, and then have a separate list of things we might improve on that.
I agree.
Or like, you know, so this one, like, you know, I would just throw into one of the limitations is that sometimes, you know, we only capture display a limited number of frames, and sometimes the contents of those frames isn't what would be most useful, right?
Yes, definitely.
So
it's just something I would like to track on the long term, because ideally, it's as Peter also said, that we hopefully at some point get most of our information from the arrow itself and don't need any postmortem debugging anymore.
So, I mean, I would say, you know, let's say that that's one of the limitations, because, you know, it'd be good to have a, here's what we have, here's the use case, here's what we have today, here's our recommendations for how you you basically debug, and then here's a list of things that are still a challenge in that flow that we can work on to improve. And that, I think, falls into that category.
Yeah.
Okay, I think it would be too ambitious in this remaining 7 minutes to really go into user journey. So let's try to focus what we started, the use case and kind of the tools, what we have today. Does it sound reasonable for the people?
Sure.
Okay, so we discussed diagnostic report, code dumps, and the error properties, and what the error properties are today and what it could involve in the future. Is there any other way how we can deal with crashes? Like, I mean, I know that people have kind of different log processing, aggregation, but it all depends on the error properties basically and what's on the console output.
The other thing might be trace events, which today our story is not great on, but that's another way of, if you turn on increasing levels of tracing and you can get a trace just before you crash, that can help you understand where you're crashing, like the control flow that led up to things.
Michael, did you mean the inbuilt tracing that the V8 engine provides, the dash trace option? Okay.
Yeah, but we have support for that in Node as well. We just don't have a lot of trace points. We could introduce more trace points. Like that, if you have an actual C level crash, that can help. In terms of the exceptions, sometimes it's a bit harder because, you know, you've already unwound for where the actual error happened. But it can still give you an idea of like, what were you doing before you got, you know, into the problems. And in fact, you know, you could, depending on the level of trace you turn on, you know, if you turn on stuff that even shows you what, you know, methods are being run, you might be able to see in your user code what caused the exception.
Yeah. The trade-off with the trace option is, on one hand, it is very good in the sense it penetrates every JavaScript method, and with trace points every C++ method as well, with the most useful information. But on the other hand, it's little bit less consumable because the large amount of data it produces makes it literally impossible to be used in the production. And more importantly, there is no control mechanism for us to be able to say start tracing only when this method is kicked in, or start tracing after this many hours. That kind of a controlling mechanism is not there. So you end up in tracing from right beginning and produce a lot of data.
Right, but that is something that we could improve on again.
Yeah.
So like, you know, I if we want to have like a comprehensive list of you know, what you can use to investigate these crashes, probably still belongs on the list. It might be that, like, given the current state, it's not near the top of our recommendations. But it could be, for example, like the things you just mentioned, like, hey, I want you to start tracing, you know, when something happens or after a certain amount of time or whatever, those kinds of things, or turn it on when this happens, and then trace for a minute and then turn off or something, right?
Yeah. And yeah, in general, if you can customize the scope for tracing, that would you know, drastically improve the user experience with the trace option, not only in the crash diagnostics, but also for say, for example, a module developer or an end user wants to debug a specific module, so he could turn on the tracing only specific to a module and get the control flow specific to that module, rather than doing a live debugging throughout
Yep.
the code control flow. You just turn on the trace, which has a filter that applies only for the specified module, and everything else is taken off in the list.
Right.
So what he sees is a control flow that is flowing through the interested module alone.
Right. Yeah, something like that. Because yeah, you could see you get a crash, you get an exception. Maybe you can tell what module it's in, but you can't quite tell how it got there. If you then enable trace.
Okay, we are running out of time. So I think we kind of collected the use cases and kind of collected tools, what we have today. I think what we could do offline is kind of describing what is the user journey today, so like what it means to using diagnostic report, or what it really means to using columns. Giresh pull request actually did a great job there. So I can copy information to this document. And so I think we can do that offline, and we don't really need to be in a meeting to do that. But probably what we need to be in the meeting is we need to agree what we want to document. So what actually we want to recommend to the people to do and how to do it. And then the more interesting conversation, which we kind of started to touch when we were talking what it could be, the error properties, what it could be, the trace points, is what would be the ideal user journey and the ideal tool. So I think that could be a really interesting conversation, that why we have 3 different tools today to do this, or 4, how we could make it one which is working on every platform. I don't expect that everything is possible because we have some technical limitations, but that could be an interesting next meeting. Does it make sense to kind of finishing offline this, what is it today, and having a meeting about what we recommend and what the future could be?
I think so. The thing I'd say though is, like, I don't know that we need to pull it all into this one document. You know, like the under the documentation crash, there's the sort of the crash setup, because I think there's kind of there's gonna be like, what do you need to do in advance so that you're ready when it happens? And that's, you know, part of what Jarish has put together there. And if we can actually agree on that and land it, that smaller piece, I think that's good. Then the next step would be the, okay, now your application is crashing, what do you do? And then we could talk through, and in my mind, it's kind of the layered thing of like, hey, if you got a stack, if it crashed and you got an error and it's printing the properties, here's maybe what you want to look for, and if that helps you solve it, great. The next recommendation is to, like, you know, use diagnostic report to get some more information and some detail on that. And then finally, if that doesn't work, you know, you can spin up LL Node or possibly tracing, and here's what we recommend you do today. Now, you know, and can we make those like a set of, you know, consumable recommendations? Like, it could be that even that should be layered, where it's like that next document says, here's the flow that we recommend, and then here's a link out to, like, well, how do you use diagnostic report and what to look for, and how do you use LL Node and so forth, right?
Okay.
Because even just understanding that, like, hey, here are the tools and here's the order that we recommend them makes sense, I think, and is probably useful. And then with the pointers on how you actually do the more detailed investigation.
Should we do this in the current open pull request, or should we create? Should we merge this one and create more? I know it's open for like months, which is not ideal.
Yeah, I would almost say, like, you know, if we can agree that that's a reasonable recommendation for setting up to be ready for crashes, we should land that. And then, you know, we could add another document underneath crash, which is like the README that says, okay, you know, you need to, you know, crashes, here's some of the, you know, could have here's some of the use cases, and maybe point back to the larger document that says, you know, you've got this situation, here's the summary. Now, what do you do? Well, first of all, make sure that, you know, you're set up, point over to the setup document. Second, here's the sort of initial steps we recommend. And that document could be its own thing. And then we could have new documents that go in there that are like, how to use diagnostic report, how to use core dumps, how to use error properties.
Okay.
Does that make sense? Or it's just sort of a way so that you can read to whatever level that you want to at a particular time.
Yeah, I think it makes sense. It's like we already know that although code dumps is very powerful, it's like nobody really wants to use it because it's really complex to use it. But
Right.
the flow, what you described, it really makes sense. That let's start with the most simple one, the most powerful one, and if you need to do more complex things, then this is how you do it.
Right. And I think we should, like, personally, if we can break it up a little bit like that, if we can land little pieces, like even if we just land, like if the using core dumps LL node, if the initial thing we land is simply like a collection of links to articles or things that are already public, that's at least the starting point, right? And we could land that. Then the next step would be to go through and actually extract the most important information and put it into the doc itself, right?
That's a good idea.
I'm just worried we'll get stalled if we try and like document everything at the same time, right?
Any volunteer who can come up with just the structure, so not really the content, just the structure, what we discussed now?
I'll volunteer to work with Jarish on that. How about?
Okay, thank you.
So maybe if the ask could be, you know, it would be great to just land this crash one. We can always adjust later if we think the content's useful and reasonable, right?
Okay, yeah, just what I meant, having the structure, what we want to achieve on a long term. Even if we right now we don't even link them to external articles, just to do, just kind of having a picture. And
that's what we'll do. We'll look at, you know, either the README with the links or empty versions of files that would go under crash. How about that?
Okay, cool. I have to go and we're running out of time. Is there anything that we should discuss now? Or I would recommend that in 2 weeks, let's do the normal diagnostic meeting, kind of with a little conversation, how to proceed on this one. And then the next one could be again a deep dive on either continuing this one or touching other topics.
Yeah, makes sense.
Okay. Then thank you everyone and have a wonderful day.
All right, talk to you later. Bye.
Thanks, you too.